Bueno, aquí estamos ahora en este que les mencioné de Grid Edge Theater, DC Power Zone. De verdad fue bien interesante el training que cogí. Tengo la oportunidad de entrevistar a dos de las personas que han trabajado con esto. Voy a cambiar al inglés, pero le vamos a poner los captions, ¿ok? Así que, hey Dusan, how are you? Angel Sayas here. Tell me your name and the company, and let's move on, ¿ok?
I'm doing well. My name is Dusan Berlik. I'm the co-founder and CEO of Direct Energy Partners. Our company designs a microgrid design tool called DCID and a microgrid controller called the Power Platform.
Great, very good. And who do we have here?
All right. Hi, my name is Giel Vandenbroek. I'm the co-founder and CTO of the EP. And on a day-to-day basis, working a lot on these software solutions that we're building to accelerate the microgrid industry.
Very good. Thank you very much. It was great for me to be in the workshop yesterday, understand a little bit about what was really happening in the future. So tell me in a couple of minutes, how do you see the future, and then how do we see with all this equipment that you have in test here, and that actually there are some projects that you are doing, so go ahead.
Oh, fantastic. Well, first of all, we believe that the future is DC, and what we are working on is we're trying to enable the market and reduce the soft cost and the knowledge gap associated with the design, engineering, and deployment of DC microgrids. And so what we have here is we have a live testament and a demonstration of a multi-vendor DC microgrid. We believe the future has to be multi-vendor, and it's going to be DC. And so we wanted to prove to the world that you can connect various converters with various batteries and various controllers. So I can walk you through what we have here. Wonderful. So this is our a software tool called DCI.app. We designed this Grid Edge Theater inside the app. And you can see there's a single line diagram here that shows how everything is connected. So the heart of the system is the Savant battery. It's a residential battery system. It's 20 kilowatt hours with an inverter. It can generate AC power. It can take AC power to charge the batteries, but it can also output DC power. And so it's a really good standalone unit. Now, we wanted to generate DC power for the DC loads at the Grid Edge Theater. So we said, let's pick another vendor, and we've chosen C+D that acts as a DC-DC converter effectively. So now one vendor is taking DC energy from the battery and generates a DC bus. We've chosen 350 volts DC. We believe for residential systems, that's what the voltage is going to standardize, and you will find commercially available equipment. So what do we have equipment-wise? Here you'll see we have a residential train HVAC system that runs on 350 volts DC. We have a fault-managed power system that runs the lighting system from Sinclair Digital. And we have a few EV chargers that are not connected to the system because we don't have an EV car, but they're DC coupled and available. And the way the system works is we run everything off the grid, and then we can charge the batteries from the grid. We don't have solar connected, but technically you could connect solar there as well. There's a controller that runs the microgrid. Today we're actually introducing this to the market. It's a Power Platform. It's the first open microgrid controller that anybody can write their code on and connect with their database. So we're really excited about that. Here you see the live data being streamed of the microgrid operation from our controller. So you can see the battery state of charge is 70%, and the battery is discharging at about 1.69 kilowatts. And so you see how much AC and DC loads that we're consuming here.
So let me ask you, can you show us the equipment quickly here that you have presented in the one line, just briefly to show to the people?
Absolutely. So let's take you over here. So this is the Savant battery that I mentioned earlier. This is 20 kilowatt hours of energy storage with a 12.5 kilowatt converter. Now this unit on its own is fantastic. It can take solar directly in, it can take AC in, and it can also generate its own AC power. But what Savant does that most people don't do is they allow you to take a DC tap out, so you can connect multiple DC systems together.
Very good.
And then this is the C plus D. It's a 30 kilowatt unit. It's for commercial applications, but we show you that you can connect commercial and residential together. So this is 3-phase power. It's bidirectional on the AC port, bidirectional on DC port for the batteries, and it generates the DC bus voltage for the rest of their loads out there.
Very good. Very good.
So this here is our control panel product. So our controller that looks like this sits inside here, and that operates it. But all the rest of the stuff that's in there, it's called the balance of systems. So we integrated everything, so with the push of a button, you can say start a microgrid and stop it, and it can run your microgrid. So that's that. This is the volt server. This is called, from Sinclair Digital. It has fault managed power. This is really cool because on small gauge wire, you can run 350 volts DC without conduit. Fantastic. This is a DC distribution panel. So we're showing various ways to distribute DC, whether that's through a direct connection DC panel or through a volt server wire. So let's take you to the load center.
Where's the plugging?
So this is what we call our load zone, the DC load zone. So you see like back there, there's like a receiver coming from the volt server, and so we can take power coming in, and we can distribute both power and data on the same lines. So this year the volt server is controlling the lighting for the Grid Edge Theater. This is a really cool product. It's called a mini split. I believe it's UL certified, and it takes DC batteries, DC solar in, which means you can have air conditioning without any kind of utility connection. And this is like, you know, a small residential system, a room system you can have. And this is more of a centralized home air conditioning system that you typically see in US homes. And this also runs on 350 volts DC out of the factory. And then we have a couple of EV chargers over here. This one is from Intelligent, and this one is also made to run EV charging. So you see that, you know, manufacturers are putting devices out on the market that are DC, so the DC future is around the corner.
Well, thank you very much. In all honesty, it was very well explained, and I believe in the DC for the future. So thank you very much, Dusan, okay?